So in this video, we're going to start with exercise 8.1 from chapter number 8, quadrilaterals. So let's see what is question number 1. Yes. So the question number 1 reads, the angles of a quadrilateral are in the ratio 3 as to 5 as to 9 as to 13. So this is the ratio of the angles of a quadrilateral. Find all the angles of the quadrilateral. This problem, as you might remember, is based on something called as angle sum. Okay, angle sum property, angle sum property of a quadrilateral. And what does this property say? It says that sum of all angles of a quadrilateral is equal to 360 degree. Okay, all the angles of a quadrilateral, any quadrilateral. So let's say if this is my quadrilateral, okay, like this. Let me use straight lines. So let's say this is my quadrilateral. Okay, so in this, oops, so in this quadrilateral, okay, the sum of all the four angles, so angle number 1, angle number 2, angle number 3, angle number 4, all these four angles summation is equal to 360 degree. So we're going to use this property of a quadrilateral to solve this problem. Now the key information given to us is that the ratio of the angles is 3 as to 5 as to 9 as to 13. This is the ratio of the measure of the angle. Okay, so all I'm going to say is this is step number 1. Let the common ratio, let the common ratio between angles be x. Okay, let x be the common ratio between the angles. Okay, therefore, so okay, so step number 2. So the angles will be, okay, so the angles will be, what will be the angle? So first I have yes, so first we have 3, so the angle will be 3x. Okay, then next I have 5, so the angle will be 5x, and then next I have 9, so the angle will be 9x, and last but not the least we have 13, so it's going to be 13x. Okay, so these will be the angles of a quadrilateral. So let's say this is our quadrilateral. Okay, let's say this is our quadrilateral, then the angles are 3x, 5x, 9x, 13x. However, the summation of this angle is 360 degree. Okay, so we can write, but 3x plus 5x plus 9x plus 13x is equal to 360 degree. Okay, so basically what we have done is we have got an equation. Let me use a highlighter. We have got this equation with one unknown variable x, and we have to solve this equation. So we are going to do the summation. So 3 plus 5 is 8, 8 plus 9 is 17, 17 plus 30 is 30. So therefore we have 30x as equal to 360 degree, and therefore we have x as equal to 360 divided by 30, that is equal to 12. 12 3s are 36. Now all we have to do is substitute this value of x, which is 12, in these uh, variables, and we will get the angles of the quadrilateral. So I'm just going to, okay, I'll just make an arrow like this. So we're going to substitute x equal to 12, and we'll get the value of all the angles of the quadrilateral, which is what the question is asking. So I'm just going to do it here, or rather, okay, I'll just move it aside. Yes. So the first angle was 3x, which will be 3 into 12 now, which will be 36 degree. Then the second angle was 5x, which will be 5 into 12, and thus that will be equal to 60 degree. And then the third angle will be equal to 9x, that was 9 into 12, and 12 nines are 108 degree. And the fourth angle is 13x, that's going to be 13 into 12, that will be 12 3 is 36, 3 1 carry us 156 degree. So The four angles that we want is 36 degree, 60 degree, 108 degree and 156 degree. These are the four angles that the question was asking us to find. Let's read the question again. Find all the angles of the quadrilateral. So these are all the angles of the quadrilateral. Now, this was first question. Moving on, we have one more question under exercise 8.1 and let's read what the question is. It's question number 6. Now the diagonal AC of parallelogram ABCD. So ABCD, this is a parallelogram, and diagonal AC bisects angle A. Okay, so the key word is bisects angle A. So this is our angle A. Show that, okay, now we have to prove that it bisects angle C also. So where is angle C? So this is angle C. So we have to show that angle C is also bisected. That is the first thing. And the second thing we have to show is ABCD is a rhombus. So ABCD is not just a parallelogram but is also a rhombus. So first we'll focus on point number 1. This point number 1, that it bisects angle C also. Now let me remove this so that we have better understanding. Now note this, that we know ABCD is a parallelogram. Okay, so AD is parallel to CB. Okay, line AD is parallel to line CB. Why? Because that's a property of parallelogram. Opposite sides are parallel to each other. Now consider AC, this AC, as an intercept to these two parallel lines. Okay, if it's an intercept to these two parallel lines, then this angle, which is DAC, okay, DAC is equal to angle ACB. Okay, why? Because of alternate interior angles. Okay, so this angle will be equal to this angle. So once again I'm going to erase this so that we understand it carefully. Okay, let's zoom a bit. Yes, so these two angles are equal. Let's call this as x and this as x. Okay, because these two angles are equal, that is given to us. Now what the point we are trying to make is, let's in fact come here. Point number 1 is angle DAC is equal to angle ACB. Okay, I'll trace it. I'll trace the angles. DAC is equal to angle ACB. Okay, why? What is the reason? Because they are alternate interior angles. These are alternate interior angles for the parallel lines. Which parallel lines we are considering? CB and AD, for these two parallel lines. Now let me erase this, the highlighted part. Okay, now consider these two parallel lines. Let's use the highlighter again. DC is also parallel to AB. Okay, we know that line DC is parallel to line AB. Why? Because they are opposite sides of the parallelogram. And once again you should observe, or you should consider AC as an intercept to these two parallel lines. Now if it's an intercept, then once again we have, let me use, yes, we have this angle DCA, this angle equal to CAB. Okay, so I'm going to write it down. Oops. Okay, so we have second point, angle DCA as equal to angle CAB. Okay, and what is the reason? The reason is exactly same as this, because they are alternate interior angles. Copy and paste. Why? Because they are alternate interior angles. For which two parallel lines they are alternate interior angles? For DC and AB. Okay, so I'm going to erase this so that it doesn't look messy. Yes, and in fact let's also erase this. So we have, okay, so focus on this statement, angle DCA is equal to angle CAB. But what is angle CAB? Sorry, we have to change this. Angle CAB is x, so this will also be equal to x. Okay, so yes, so this will be x. Similarly, this also will be x. Okay, from this statement. Okay, ACB, this is ACB is equal to DAC. DAC. So this angle is x, this angle is x, which obviously means that angle C is also bisected. It is also bisected into two equal angles. So that becomes the proof of our statement number 1. Let's mark it as done. So we have proved that diagonal AC, yes, here it is. So we have proven that diagonal AC, this is our diagonal AC, it bisects angle C also. Now, let's focus on the second statement. The second statement says we have to prove that ABCD is a rhombus. Now, first of all, we have to understand what is a rhombus. So that's a quick revision. Rhombus is a type of a parallelogram where all sides are equal to each other. So, all sides are equal to each other. That is the property of a rhombus. Okay. So, if in a parallelogram, so let me in fact write it down here because this is an important statement. Let's draw a line here. Yes. So, point number 1, first point, that ABCD is a parallelogram. This is given. Okay. ABCD is parallelogram. This is a given piece of information. Okay. So, AB is equal to DC. Okay. And AD is equal to BC. Okay. Why? Why is this the case? Because once again, I will use this. Okay. Why is this the case? Because they are opposite sides of a parallelogram. Opposite sides of a parallelogram. So this is a property of a parallelogram that opposite sides are equal to each other. So let me mark it. So AB is equal to DC. In fact, let's use a different color. So that's clear. AB is equal to DC and AD is equal to CB. Okay. Now, focus on this triangle. I'm going to highlight it. Yes. Focus on this triangle ADC. I'm going to highlight here now. ADC. This is a triangle. Okay. Let me try to zoom in so that now in this triangle, if you note, this angle is equal to this angle. Okay. In triangle ADC. Okay. In fact, let's make a statement here. So, in triangle ADC, angle A is equal to angle C is equal to x. Okay, we have just proven that this is x, this is x, this is x, this is x. So anyway, just focus on this highlighted triangle. So this x is equal to this x. Okay, that means therefore triangle ADC is an isosceles triangle. Okay, why? Because that is the very definition of isosceles triangle. If the two angles are equal to each other, then the triangle is called an isosceles triangle. And if it's an isosceles triangle, then very important, then AD will be equal to DC. Okay, why? Because that is the property of an isosceles triangle, that the sides which are opposite to equal angles, they are also equal to each other. So AD, okay, this AD is going to be equal to DC because it's an isosceles triangle. Now AD is equal to DC. Now let's come down here. Yes. So now I'll try to zoom out. However, so now I'm going to make point number 3. But AD is also equal to DC. Okay, just now we proved because it's isosceles triangle. Because triangle ADC is isosceles. Okay, so now look at this. AD is equal to DC, but AD is also equal to BC. Okay, therefore, and DC is also equal to AB. So if we prove that this is equal to this, then all four become equal to each other. So thus AB will be equal to DC, will be equal to AD, will be equal to BC. Okay, because AD is equal to DC. Now, all the four sides of the quadrilateral or of the parallelogram are equal to each other. Okay, focus on this statement. We have got all four sides equal to each other in this parallelogram, and thus by definition this parallelogram will be a rhombus, which is what we noted down, that this is the definition of a rhombus. So thus we have also proven point number 2, that ABCD is a rhombus.